This video will show you how to subtract integers, and I'm going to use the chip model. So this problem states that we have positive 9, which could be represented with 9 positive chips, and you could represent 9 positive chips by simply writing down 9 plus symbols on a piece of paper with pencil or pen. Then I'm supposed to take my positive 9, and I'm supposed to take away positive 5. Meaning of my 9 positive chips, I am to subtract or take away 5 positive chips. So you can think of this as we're subtracting a positive 5. So taking away 5 of them, 1, 2, 3, 4, 5, if you were to take them away, you'd be left with 1, 2, 3, 4 positive chips, so the answer would be 4. So I'll use this method on a more difficult problem. For example, in this problem, I have the number negative 9, and we are to subtract the number negative 5. So I will start with the negative 9. I use 9 negative chips to represent the number negative 9. This can be done by just writing 9 lines representing 9 negative chips. Now I have a couple choices of how to do this. One method to do the problem is to take the negative 9, leave it alone, and change the subtraction problem into an addition problem. If you did this, if you changed the subtraction to addition, you'd also have to change the sign on the second number. Changing the sign on the second number would be a 5. So one way to do the problem is to take my 9 negative chips and then add on 5 positive chips. So here I've added 1, 2, 3, 4, 5 positive chips. Then I could say that a positive chip and a negative chip cancel each other out, so these would be gone. These pairs would cancel out and be gone, leaving me with 1, 2, 3, 4 negative chips, and my answer then would be negative 4. The other way to do the problem would be not to change the subtraction problem into an addition problem and leave it as it was. So I started with 9 negative chips, so here's the number negative 9, and I represented it with 9 negative chips, and we are to subtract off or take away 5 of the negative chips. And if you did that, here's 5 of the negative chips, and if we were to subtract those 5 negatives, they would go away, leaving me with 1, 2, 3, 4 negative chips, leaving me with the number negative 4 as my answer. I'd like to do a couple more examples. In this example, we have 9 subtract a negative 5. Again, you have a choice. One way to do the problem would be to change the problem so that it's not a subtraction problem but an addition problem. So I have the number 9. I leave that alone. I change the subtraction problem into an addition problem, but if you do that, you have to change the sign on the second number. So rather than it being a negative 5, I would make it a positive 5. This turns out just to be 9 plus 5, and if you had 9 positive chips and added 5 positive chips, you'd end up with 14 positive chips, leaving you simply with the answer 14. If you didn't think about changing the subtraction problem into an addition problem, you could do the problem by saying that you start with 9 positive chips. So here are my 9 positive chips, and we are to subtract off 5 negative chips. The difficulty here is I don't have any negative chips for which I have to take away. So I have to introduce some positive-negative pairs. By introducing a positive chip and a negative chip, because they cancel, I'm still left with my 9 positive chips, not changing the value of my answer. But having done so gives me a negative chip, though, for which I can take away. The problem is I need 5 negative chips to take away, so I will need to introduce 5 of these positive-negative pairs. So here I have it. Here's my 9 positive chips. I introduced 5 positive negative pairs, if you will. 1, 2, 3, 4, 5. Having done so, I haven't changed the value of my expression. I still have 9 positive chips, and I essentially added 0 multiple times. But now I have 5 negative chips here, and I am to take away 5 negative chips. So if I were to do that and take my 5 negative chips and subtract them off, what I'd be left with is many positive chips. I need only add them together to see how many I have. Here's the original 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, and I would have total 10, 11, 12, 13, 14. Again, we get the final answer to be 14. In this example, we start with 9 negative chips, and you can represent that just by writing 9 negative symbols on a piece of paper. One method to do the problem is to change the subtraction problem into an addition problem. If I did that, that would look like this. You always leave the sign on the first number, change the subtraction to an addition, but then you must change the sign on the second number. Since the second number is a positive 5, I would have to change it to a negative 5. Now what this would mean is that I have 9 negative chips here, which I've already written down, and I have to add 5 more negative chips, 1, 2, 3, 4, 5, and now I could just add all of the number of negative chips together to find out what the answer is. Here's my original 9, and I'll add on the rest. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I'm left with 14 negative chips, so my final answer would be negative 14. If you didn't think to or didn't want to change the subtraction into an addition problem, you could have done the problem in the following way. Here I have my 9 negative chips representing the number negative 9. I am to take away 5 positive chips, but I don't have any positive chips for which to take away. So what I could do is, in addition to my 9 negative chips, I could introduce a positive and a negative chip, and this would not change the value of my answer, because the positive chip and the negative chip cancel, or you can think of as a positive 1 and a negative 1 sum to 0. Now, having done this, I have a positive chip for which I could take away, but I need 5 positive chips to take away, so I need to introduce 5 of these pairs. So here's my 9 original negative chips. I introduced 5 pairs that cancel out, not changing the value of the chips. But now I have 5 positive chips for which I can take away. If I was to take my 5 positive chips and take them away, they would be gone, leaving me with several negative chips. I need only add them up to find the answer to the problem. Here's the original 9, and I'll add on the rest. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I'm left with 14 negative chips, meaning that my answer is negative 14.